We've got quite an action-packed afternoon looking at the big waste debate, but you'll be very pleased to know I'm going to sit down and shut up and leave it in someone's hands who is much more competent than me at this kind of thing. And so to chair the afternoon session, I'd like to introduce Nina Warhurst, who's the BBC North West political editor. Nina.
Good afternoon. That was my first ever time trying a roulade and it was lovely. Bit of information. So I am the BBC's political editor for the North West, so I cover 72 constituencies from Barrow all the way down to Crewe and everywhere in between. I spend a lot of my time driving around the patch, talking to voters about why politics is important, but some time at Westminster and lots of time at our studios in Salford. And a bit like you lot, I should imagine, I enjoy it. I enjoy going to work every day, and I like the fact that I am serving the public. I find it very important, and I'm sure lots of you have dedicated your life to serving the public similarly. It is a real pleasure to be here today, and I say that sincerely because when I was first invited to come, I knew absolutely nothing about nuclear decommissioning. I had a little bit of a crash course from Dan and Bill, and watched a video by James, who we're about to hear from. And it struck me as being a bit like Brexit, a big idea that was executed with enthusiasm and gusto in the first place, with not enough thought of what would come later. That's how I see the nuclear decommissioning process at the moment. It's fascinating to me, and I'm new to it, and you're all here as stakeholders. It matters to your local authority, it matters to your community, it matters to you as individuals and your families. And the more I read on it, I thought, actually, I'm a stakeholder. My one-year-old son is a stakeholder. We are all stakeholders in this country. Decommissioning affects everyone in Britain and indeed around the world. Just as technology accelerated in the 50s and 60s, now we have a duty to get this right. As my dad said when I explained to him where I was coming today, blimey, it's not the sort of thing you can afford to get wrong. Which is where debate comes in. There's a diverse range of opinion we're going to hear from this afternoon, and in order to move forward in a meaningful way on anything, you have to have debate, you have to listen, and you have to learn, which is where our panel comes in. The five members will be giving their views, and then afterwards it will be your chance to ask questions. We'll have a break after the third panel member, and hopefully we will all learn something new that we can take home. So, enough from me, I will introduce our first speaker. He has more than 20 years of experience in the nuclear industry. He's now the NDA Strategic Lead for Integrated Waste Management. His key areas include radioactive waste storage and disposal, graphite management, and decommissioning waste. He also represents the UK internationally, including at IAEA and NEA gatherings. Ladies and gentlemen, please welcome Dr. James McKinney.
So good afternoon. As you already heard, my name is James McKinney. I am the Strategic Authority for Waste Management in NDA. Waste, we're going to hear about it all this afternoon. So I thought the purpose of my presentation was to sort of prepare you by giving more sort of context. Phone I can hear. A bit more context to help with the ongoing discussions we're going to have. In terms of waste management, waste itself is those materials which we believe have no further use. And at that point, the waste manager takes over. They may have a slightly different view on if there's some further value in that waste material. Behind me are a set of pictures. You've probably seen these in various NDA publications, but they all represent waste areas. In the top left is a large metal object being pulled out of a legacy pond. There'll be people in this audience who may automatically know what that piece of equipment is. As far as a waste manager is concerned, that is a piece of metal. It is heavily corroded. There's no way you'd plug it back in and it'll work. It's probably been sat in that pond for 30 years, and now the waste manager has to determine the best way forward. So they have to characterize that material, they have to understand more about it and look at possibilities of extracting some value. In the top right, that's a bunker. Often in the past, we built various ponds, silos, bunkers, and we opened the top and we threw the waste in. So the information we have about that waste in some areas is not very good. So, and also what was interesting at the time, it wasn't always clear about how do you get the waste back out again. So we have to deal with a broad range of materials. In the bottom right, that's a pond at Sellafield, and some of this material, once again, has been stored for many decades. It is often heavily contaminated with radioactive material. Chemically and physically, material is not always in the best of shape. Physically and chemically, it could be hazardous as well. And interesting, because I'll come back to this later on, is a reactor core. So we talk about waste management as we're dealing with problems today, but also in dealing with our legacy in our sites, material which may have been functioning a few years ago, and we're in the process of, say, defueling reactors, that core will become waste. So the dismantling of reactors will generate lots of waste. So the waste management program is never a near-term program. I'm sure we'll talk about that a lot later on. In terms of waste management in the UK, there are a number of policies and strategies, and these are the ones that cover radioactive waste management for the NDA estate. They set down the framework, the policy framework, the preference in terms of strategic planning, and also identify areas of opportunity that the NDA, with support from site licensed companies and our waste management organisations, to develop further, looking at opportunity to optimise waste management. So radioactive waste management is a devolved matter. So in there we have UK policy, but also have Scottish and Welsh. And the documents at the front are the NDA's associated strategies. Also in the UK, we have a waste classification system. So beginning at the bottom really, or the one above outer scope, is low-level waste. In policy space, low-level waste is defined. You go above that threshold, it's then intermediate level waste. And when we have to start to consider heat in the design and operations of our facility, that material is classed as high-level waste. So what that means is intermediate level waste has no upper limit in terms of radioactivity, but once you have to take into consideration heat, it's classed as high-level waste. Just to give you a little bit more background, we will have to manage around about 4 million cubic metres plus of low-level waste. Intermediate level waste might be around about the 300,000 mark. When it comes to high-level waste, we'll probably have about 1,000 cubic metres. 95% of our radioactivity in the UK's radioactive waste inventory, radioactivity is associated with high-level waste. So that means that 1,000 cubic metres contains 95% of our radioactivity of those materials formerly classed as a waste. Low-level waste is a fraction, a tiny fraction of 1%. So that 4 million cubic metres, roughly, will contain something like 0.00003% of radioactivity. We've also, in our, across our estate, we have to think about and manage over 1,000 different waste streams. The materials are very broad range in nature. I've touched on some already: metal, graphite, plastics, ion exchange resins, filters, cladding associated with fuel, and so on and so forth. The list is endless. Just to make it a little bit more complicated, we have the waste classification system. We have a subcategory of low-level waste called very low-level waste. Not sure what's happened to this slide, but the HAW at the top, higher activity waste, is associated with those materials that include high-level waste, intermediate level waste, and some low-level waste that can't go to an existing disposal facility. Then we have a lower activity waste of those materials which we can dispose of. The outer scope are wastes that, because the radiological content is so low, can be classed as non-radioactive. So the NDA strategy comprises of 4 driving themes. I'm sure most people are familiar with them, but waste management is one of them. Integrated waste management is the one in orange. And I often see it as a supporting strategy to the other driving themes, especially when we talk about site decommissioning and remediation. David Peaty talked about a chimney today. If you haven't got a waste route, you won't be pulling down that chimney. When we talk about reactors, so tomorrow, Simon Boniface will talk about Magnox reactors. If you want to dismantle a reactor, you need a waste management route. So waste management, I see it as a very supporting strategy, and as well we talk about these 13 critical enablers at the bottom. Haven't got time to talk about it today, but I just want to leave you with the impression that integrated waste management is essential in the delivery of our program. So waste management, we have to consider the whole life cycle. There's been a lot of discussion already about geological disposal, but that's the end of the journey as far as we're concerned. At the beginning, we have to think about how we retrieve the waste from those existing facilities, or how we dismantle facilities so the waste arises, and then we have to condition that waste. So if we pull out a waste from an existing bunker or pond or silo, that waste more than likely will not be suitable for storage and disposal. So we have to condition it. We have to do something to that waste to then put it into a form that is suitable. Often that involves things like maybe drying the material, it may be decontamination, it may be we have to cut it up because it's a very large object, and then we're normally in place into a robust container, and typically we then pour grout into it to make a solid block of a waste package. So these are the various steps. So we've got the retrieval, then we condition the waste, we place into safe and secure storage, and then we look at the end point, which is disposal. And the difference between disposal and storage is when it comes to disposing of material, there is no intention to remove that material again. Storage, you've got to think about the import and the export to get that waste into that storage facility and back out again. So also the title of the talk was talk about 30 years from now. So 30 years from now, I totally expect that all our legacy waste that exists at this moment in time would be retrieved and treated and placed into safe storage. I would also hope that a considerable amount of this infrastructure exists. So we can start to think about how to optimize the whole of this waste management life cycle. So waste management is a series of steps. It's a journey where we take the waste from where we are today, put it into a form which is safe to store and ultimately to dispose of. This is a picture you see in our strategy, and this is our higher activity waste inventory across the NDA estate. So that is high level waste, intermediate level waste, and some low level waste. You can't see the high level waste inventory in there. It's hidden behind that big green blob, peaks and troughs, which is really the intermediate level waste. The other thing to note is the NDA estate really dominates when it comes to radioactive waste. We own some 90% of the total inventory that we have to manage through the fullness of time. We've only packaged, in terms of things like higher activity waste, only about 10%. We've got a long way to go. And this is the volume that will rise over time. So starting pretty much today, this actually goes back to 2013, and the end of that schematic is 2098. If you then added EDF energy and MOD arisings, they'll extend a little bit further into the next century. So we really are talking about a century of waste horizons. I could change the axis, that's volume. We could have put radioactivity. It will be a completely different graph. Over the next few decades, probably up to, you can see the big peak start to rise in about 2070. That waste is totally dominated by our activities at Sellafield. Not exclusively, but a lot of the waste underneath that line is associated with the Sellafield legacy ponds, retrievals, some of the decommissioning activities, etc. Sellafield does dominate the landscape. The big peaks at the end are associated with Magnox. the Magnox reactors. So that are the waste streams dominated by, in particular, graphite, concretes and steels. And so the peaks and troughs at the end of that scheme, the back end of this century, are associated with Magnox. What's interesting is this is an estimate. This is assuming the current plan goes ahead as is. It is an estimate of what will happen in the future as a prediction. So if you change your timescales with respect to decommissioning, you will change that profile quite dramatically. And they're going to talk about timing of Magnox reactor dismantling tomorrow. So you can see that our waste management landscape could change quite dramatically depending on the outcome of that study. So in terms of integrated waste management, the NDA has produced its theme, integrated waste management theme, and within that we describe 7 principles, which is our top-down view of the main areas we're really interested from a strategic authority perspective. So at the top we've got risk and hazard reduction, and we work our way around clockwise, the waste management life cycle, the waste hierarchy I'll come back to in a minute, characterization, so really understanding about the waste we've got, moving around, sharing capability. As you can imagine, waste management is never that cheap, and the ability to share infrastructure and work together across the estate is really important to us. Robust decision making. We would expect when we make decisions they're robust and underpinned. And also we need infrastructure that's going to last an awful long time. We already talked about the landscape for waste management being throughout this century and beyond. So these are 7 principles. We use those to really start to understand what are the key areas in terms of waste management from an NDA perspective. I'll put this diagram up, and I always say you can't read it, but it is in our strategy. The thing I want to get out of it is the blue area is our high activity waste, the orange in the middle is low level waste, and the green is out of scope. Coming down is the life cycle. So starting with retrievals, and you talk about preconditioning, so you might want to pre-treat the waste, treat the waste, store the waste, etc., and then finally dispose of it. So the message is, when it comes about integrated waste management, is seeing the bigger picture always. Traditionally in the past, a project would be responsible for retrieving waste from somewhere, and it would have probably only one answer in terms of waste management. If it's intermediate level waste, or assumed to be intermediate level waste, we'll retrieve the waste, treat it, store it, pending final disposal. But it's not like that. There are opportunities to do something different with that waste as you go forward. There's opportunities to extract value from the waste. So these arrows are illustrative, but they are highlighting examples of where you could probably do something different with the waste. So for example, challenge the assumption it is intermediate level waste. Go back and characterize it, and you may find it's actually low level waste. It's been in there a long time. Somebody went in there 10, 15 years ago and made an assumption. Challenge that position. If you can't do that, it's still intermediate level waste. Can you clean it up? Can you decontaminate it? Can you sort and seg? Can you separate some of the intermediate level bits of that from the low level waste? If you had a piece of metal and the corner of it was heavily contaminated, if you separated the contamination from the rest of it, would the rest of it be low level waste? This is a dynamic. So the integration is about seeing the holistic approach and recognizing there are opportunities throughout the life cycle, but also going from left to right. So if you have to come down a particular arm, you can always look at things like minimizing the waste. So don't challenge the position that you can't do something else with the waste. For example, we can crush material. Supercompactors exist. We can crush the waste and create a smaller volume. So what we're trying to do is get the sites in particular who are doing this. They're doing some really good work in this area now of seeing the bigger picture. And integration also means see the bigger picture, but recognize that waste management is there to support other strategic areas. So waste management in isolation is an integration. Think about how you can support site decommissioning, remediation, or spent fuel management. So we think about planning, preparation, treatment and packaging, storage and disposal. Planning and preparation is really important because that One establishes the baseline for what technique you would put in your baseline in terms of working with that waste area, but also identifies opportunities, and you'll work on those opportunities in parallel and seek different solutions going forward. And when you've secured enough evidence, you made the clear case, you've articulated the benefits, and you can clearly see the benefits over the current baseline, you can change the baseline as well. So waste management. So really, this is a final slide, and I was going to show a short video. So the final slide, this is from the Low-Level Waste Repository's website, and at the top there we've got the waste hierarchy. So LLWR Limited have worked hard over the last 10 years or so to really implement the low-level waste strategy, the waste hierarchy, and we have a pronounced impact. This impact is real. Back in 2009, when a site generated waste, it disposed of 95% of it, and there was only 5% diversion. LLWR Limited have worked hard to introduce new services that allows the diversion away from LLWR itself, so from the repository. Because the point being, back in 2008-9, we were filling up the repository very quickly. Now, we have quite a lot. Be fair, Dennis, we've got a lot of spare capacity within that repository. And at the moment, that says 2015, so we've got a 85% diversion, so we flipped it completely the other way. And I also look forward to seeing the 2017/18 version of this, but I believe we're still heading towards 85% and above in terms of diversion. So we're almost getting towards 90% diversion at this moment in time, because we've thought differently about the waste. We thought about extracting value out of it in terms of reuse, recycle, but also we've created new routes. So we talk about strategy, we talk about policy, but ultimately it's about delivery, and this is just an example of waste management in action where we've made a real difference to the estate. I'll leave it there. I think I've got a video now to be played, so thank you very much for your time. Thank you.
So the first thing we're going to do is where we've got these red squares in each of the corners, we're going to drill circular holes which are going to be our cores. Following that, we're going to join the dots with where the yellow line is with a track saw, each of the linear cuts there, and then following that we use a concrete chainsaw to plunge through and make the breakthrough cuts. So that cutting work's going to take roughly 2 weeks from when we make our first core to the final plunge cut. So we've got a monolith containment bag, which is a thick armoured bag which we use to contain the radiological inventory in the compartment, and also keep the argon over the inventory and keep any oxygen from going in. Once that monolith is pulled back into the bag, we then close the silo doors down, and then that contains all the argon into the facility, and then that allows us to back down the monolith containment bag to remove any of the argon, and then we can take the bag off and you're left with a sealed door on the silo. So it's a contractor-led operation. They've done this 5 times already at the site, so we did a number of trials that sort of increased in complexity as we went, and then we ended up with a full integrated works test where the guys were fully suited, NDA equipment, it was integrated with the door, and everything's gone absolutely perfectly each time. This is an integrated team with Sellafield, Cavendish Nuclear, Bechtel, and we've got Babcock Marine Technology to manufacture the doors and the rigs. So this is something that UK PLC can be proud of with the precision engineering that we've got on show here.